We're here at Wiston Junction, just south of Leicester. We're doing some flights with a drone to look at inspecting switches and crossings in a novel way. The drone flies over the SSC, it takes still shots, and then the software that is being developed by Plough & Craven is then used to actually knit those images together to provide an orthographic image, which is 2D, and a point cloud image of the actual SSC.
The images are really large. Each image could be hundreds of megabytes in size, and we would get sub-millimeter pixels on the image, and that allows us to spot even hairline cracks within the rail.
We're looking at detail that no normal human could ever spot in their walkthrough inspections. Network Rail supporting a project like this is phenomenal for all of us because it enables us to dedicate time and resource to testing and developing and enhance our ability to capture high resolution and consistent data sets. Because of the increase in quantity of data that we're able to bring back to our servers, back to our offices, we've built a system around machine learning, AI, to do that task for us. So we're playing a giant game of spot the difference between data collection rounds. So we've been here every 2 weeks, and our computer systems are now working very quickly at spotting any critical issues with that rail so that it can be rectified.
The footage itself is going to be enabling us to take measurements when we look at track gauge, for example, and also look at images to actually compare one inspection with another.
If you zoom into the image, you can pan around the picture as you would normally navigate a map. And what you can see is on the left-hand side is the first visit, the right-hand side is the second visit, and there's a slider in the middle. The slider shows you the differences between the two images that were captured on different dates. And if I zoom into where I've added a flag, you can actually see that the clip has moved. If I turn off the image recognition, you can clearly see that the clip has actually been changed. We can use photogrammetry techniques to convert the images into a point cloud. This then allows us to model the data into 3D models, and this is effectively a 3D viewer of the point cloud that we've collected. So you can see my camera position is in the view, and I can navigate around the scene. This allows the user to do various things, but the main points would be to measure distances, take coordinates of locations, but perhaps the most significant use case for it is if I zoom out, I can actually activate the UAV images that were actually taken on site. But what this allows us to do, if I remove our measurement tools, is we can hover over the image and it will project the image boundary onto the ground. So in this location here, say I wanted to read this label that's on this box, I can come back up to the images and say, well, that image there holds the information for that box. So if I click on the image, it will put me in a viewer where I can then zoom into the image and read that label within the box. Our main focus is to collect data efficiently, and we can fly the drones whilst the trains are running without risking safety of staff.
Keeping boots off ballast, as we say in Network Rail, to actually move away from having people physically inspecting the track.
Behind me is the J-Weld Discrete Defect Repair Machine. It is a fully automated machine for the repair of discrete defects on plain line rail. The clamps are going to go into position now, secure it, after which we'll start the milling operation.
So I'm here today for the initial trial of the DDR unit, with the next step being that we're going to trial it on the southern region.
It's been developed to replace a manual process that is dependent on highly skilled operators, and even with those we have a degree of variability that can influence the long-term performance of the repairs. So we're looking for something that will give a much higher consistency and longer-term performance.
The welding is taking place now. The welding gun traverses across the width of the rail head and does a number of traverses to cover the cavity that has been cut out. Each weld is done in sequence and then peened and cleaned. The loose scale that you're seeing on top of the weld will be removed by peening across the rail head.
Well, the main benefit I can see of the DDR machine to both routes and regions is the lowering of maintenance costs, getting boots of ballast, aligning with modernising maintenance, and also providing an effective and efficient and reliable service to our passengers and customers.
This project is a fantastic example of the collaboration that the Shift to Rail programme was able to offer, working not only in the UK rail industry but also with our European partners on their rail networks.
So this is an excellent example of both the routes and the central business team working together to give a real benefit to the bigger business and our customers.
As a project management graduate, it's great to be part of really exciting projects that I know will deliver real change to the railway.
It will deliver a far more cost-effective system for the repair of defects and provide benefits for the railways as well as the passenger community.